The following video will go through and explain how plate tectonics work and their relation to earthquakes. In addition, we will learn more about how an earthquake is measured, as well as other factors that contribute to the extent of damage it does. Lastly, we will discuss the relationship between earthquakes and tsunamis. The crust, which is the outermost layer of the earth, is broken into tectonic plates that move in relation to one another. Tectonic plates can be made up of either oceanic crust, continental crust, or a combination of both. Oceanic crust is located beneath deep oceans and consists of mainly basalt, which is a heavy and dense rock. Continental crust is located beneath the Earth's continental landmasses and under shallow seas close to continents, and consists of lighter rock, such as granite. The majority of the Earth's tectonic hazards occur at the edges or boundaries of these plates. Different types of plate movements give rise to different types of plate boundaries, which can be categorized as divergent, convergent, and transform. Divergent plate boundaries are areas where two plates move away from each other. Convergent plate boundaries are plates that move towards each other. Plates slide past each other along transform plate boundaries. An earthquake is a vibration in the Earth's crust caused by the sudden release of stored energy in the rocks found along the fault lines. Earthquakes occur when there is plate movement along boundaries. The plate movements cause the slow buildup of stress on the rocks found on either side of the fault. When the rocks can no longer withstand the increasing stress, they suddenly slip many meters, causing an earthquake. An earthquake releases energy in the form of seismic waves. Seismic waves radiate out from a point of sudden energy release called the focus. The point on the Earth's surface directly above the focus is the epicenter. Most of the energy released by an earthquake travels along the surface of the Earth, causing the ground to vibrate violently. Earthquakes release different amounts of energy. The amount of energy released is described as the magnitude of an earthquake. For each increasing magnitude on the Richter scale, the impact of the earthquake becomes 10 times greater in magnitude than the previous one. The Richter scale is from a scale of 1 to the strongest ever recorded, which is 9.5. At about a magnitude of 6.0 and above, earthquakes can cause many poorly built structures to collapse, cracks to appear on the ground, and it becomes difficult to stand. Apart from the magnitude, the extent of damages caused by an earthquake may vary based on other factors such as the population density, level of preparedness of the country for earthquakes, and distance from the epicenter, time of occurrence, and type of soil. There are some hazards associated with living in earthquake zones, which includes the threat of tsunamis. A tsunami refers to an unusually large sea wave that starts to form when seismic energy from an offshore earthquake forces out a mass of seawater. The tsunami waves might start at a height of 1 meter and gradually increase in height on reaching shallower waters as greater friction slows the waves and forces them to increase in height. At the point of impact on the coast, the tsunami waves could be travelling at 30 to 50 kilometers per hour and may reach heights of around 15 meters. In summary, there are two types of crust: oceanic and continental crust. Earthquake is a vibration in Earth's crust caused by the sudden release of stored energy in the rocks found along fault lines. Seismic waves are generated from earthquakes. According to the Richter scale, the increase in the magnitude of the earthquake increases the amount of damage. Earthquakes result in different movement of plate boundaries: divergent, convergent, and transform. When earthquakes occur near the sea, seismic waves will be forced out of the seawater and result in tsunamis.